Hello.
Good afternoon.
Good afternoon, sir.
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 So there is no issue about students waiting in lobby today because I have accepted all. One student had issue yesterday, but I think today there is no issue at all. So keep your mic off when you are not interacting with me. You have to keep your
Good
mic
afternoon, sir.
off. So you should keep your mic off so that others will not get disturbed. Okay, so last time, yesterday we were talking about uh, natural numbers, right? And I told you some name of a book. Today I will like to tell you one more book that you should read, which is again written by S. Kumaresan that I told you yesterday. So So name of this book is Foundation Course in Mathematics. And this author is Ajit Kumar. Uh, S. Kumaresan. B.K. Sarma. So again, this is not costly. It is 200, 300 rupees book. So everyone should read this because some fundamental concepts are given in this book that will be helpful you to understand mathematics in future. Okay, so so last time
Excuse
we
me,
were
sir.
yes.
Sir, yesterday on WhatsApp group, physics ma'am Alka ma'am gave something about the courses. So
Yes,
which courses are included under that?
which courses? Uh, just let me check it. What you are talking about?
Sir, they are the courses under Coursera. She just mentioned.
Okay. That is the online courses you can
Sir, regarding
do.
what, but which all courses are included? Can you just
See,
briefly
Which
tell?
there are
yeah,
two
same
things:
question.
online courses. These courses has nothing to do with our course, our regular curriculum. There is Swayam government website, HRD ministry website, where you can find courses, NPTEL, and Coursera, right? So, Swayam NPTEL is a government initiative where the professors from various institutes like IITs, IIScs, or various reputed universities in India or colleges, they conduct such courses, and you just visit the website and register your name, and then you can choose course of your choice, and you will get certificate if you complete that course successfully. They conduct online exam. They have their exam centers. You have to give the exam, and you can get, see, these courses are additional courses that you can learn, because for example you are doing BSc, and some part is not covered in this course, our regular curriculum. For example, somebody want to learn C programming or Python programming, certain you can learn on these websites, on these online courses. And quality of these courses is better because reputed professors from reputed universities or colleges, they conduct such courses, so the good quality courses are there, and you can learn various courses. On the top of that, you can learn some courses in vacations also, because in vacations you have some sufficient time, and then you can spend your time on that learning such courses which are not included in your regular curriculum, right? So this is a facility which is available, and you should take advantage of it and get improve your knowledge. Right? Is it clear? So any doubt regarding this?
No, sir.
So you just visit the website and register yourself, and then you will get emails at time to time, and then you will find a list of courses. You can choose your stream also, mathematics, physics, whatever you want, computer science, and from that stream you can select a course of your choice and register for that particular course. And then they release online videos, online lectures, and also they release their online quiz also, test. You have to submit those tests, and at the end there will be a online exam, final exam. So in that way you will get a certificate. And there are courses for teachers also, there are courses for undergraduate students, there are courses for postgraduate students, there are courses for research students, so all kind of courses are available there, so you choose
Sir,
course of your. Yes.
sir, could you add me on the WhatsApp group? I joined your Google Classroom yesterday.
WhatsApp group. Okay, so that WhatsApp group is for all subjects, right? But I am thinking that can we have a group for mathematics only? That will be a better for our mathematics discussion, right?
Yes, sir.
Yes, sir.
Excuse me, sir.
Yes.
Yes, sir.
So there might be such extracurricular activities in our college too, now. So can you just send the links regarding that activities on the group so that we can join them?
Extracurricular activities means what kind of activities? There are
There
various
are like
activities going.
learning different languages, music
Yeah,
classes, or something like that sort. Many clubs. So
yeah,
that's all.
yeah. There are NCC, NSS,
Yes, regarding the
various
Yeah,
same.
Astro Club. Astro
So can you
Club.
just send
Astro Club is
brief us about
there.
the same? We need to join them.
There are various activities going on. So I do not have right now the links of all these things, but you can find it on website and contact the corresponding person, right?
Mayur.
Okay, so
Hello.
last. Yes.
Uh, sir, I guess Mayur is the group admin of the WhatsApp group. So
uh,
could you take my number and add me on the group?
Yeah, yeah, okay. Okay.
Okay, so you want to write my number down?
Yeah,
okay.
Yeah,
You
9158.
yeah.
Hello. 33
Hmm.
43
Hmm.
99.
Okay, I will add you.
Okay, so I will
Okay.
put the link on my Google Classroom, then you can join. So we should, there should not be any difficulty. Anyway, so, and we should not spend our time, waste our time, because our aim is to learn mathematics, right? So we should spend most of our time to learn mathematics. And if somebody feels difficult or difficulty in understanding English or asking doubts in English, so they can ask in Hindi or Marathi, no problem. Anyway, so yesterday we were talking about natural numbers. So and set of natural numbers. So set of natural numbers we denote by this special symbol. So set of natural numbers is denoted by this particular symbol n, and therefore it is this set. As I told you yesterday, these symbols are just symbols for natural numbers, and these are just symbols, not special at all, and universally accepted. So we are using these symbols conveniently in day-to-day life. So inductive properties. Property of natural numbers. So in this first property or first version, or I can say version or avatar, and ultimately you can prove that there are various you can see we'll see that there are various versions of inductive properties, and we can prove that these are equivalent, the meaning is same. So one is a natural number, first of all, that is first if n is natural number, then the next n plus 1 is also natural number. Right. So first natural number is 1, and if you choose any number, any element from natural numbers and add 1, you will get next number that is also in n. That is what the inductive property. So second property is, or the second, not second, it is same property but in different form, or you can say it's second version or second avatar of this. So let S be a subset of natural numbers. Suppose S is any subset of natural numbers, and this set S satisfies following properties, not arbitrary set. This set has if suppose S satisfies the following properties. So S satisfies following properties. So which following properties? First one is 1 belongs to S, and second one is, so if K, if you choose any member of K, then K plus 1 is also member of S. Then, right, if S is a subset, or if S is a in more general, if you have any set and it has initial element and it satisfies second condition, that if you choose any element from that set and add 1, then next consecutive element is also in S. So then S is nothing but set of natural numbers. S is nothing but set of natural numbers. So if you have any subset of natural numbers having these properties, which properties? One is a member of S, and if you choose any element from that set, then consecutive element is there, then that set has to be equal to set of natural numbers. or any set having this property is a set of natural numbers, right? And therefore, what is a set of, in more general manner, what is a set of natural numbers? In more general manner, set of natural number is a set having these properties, not like our symbols 1, 2, 3. Right, these are the symbols for our convenience. We are using these symbols for our convenience. No, the symbols are not special at all. Any set, if it includes initial element and it contains initial element, and if you choose any element of that set S and add initial element 1, and if it gives new element, that new element is also in S, then that set is like a natural numbers. And so in more abstract manner, the set of natural number is satisfies these properties, or any set satisfying this property is a set of natural numbers. Okay, so this is inductive means what? This property is inductive property means what? For example, if 1 is in S, and because of second property, if add 1, then 1 plus 1 is 2, right? So 1 plus 1 is 2. 1 plus 1 is 2. So 2 is in S because of second condition, right? But 2 is in S, therefore, and if you add 1, then 3. So if you add 1, then 2 plus 1 must be n, must be member of S. So 3 is in S. So with this logic, every natural number is in S, and therefore S is equal to set of natural numbers. That is what the meaning of this inductive property is. So now, how this inductive property help us in proving some problems in mathematics, right? That we are interested in, and therefore, what is its next third avatar or third version, right? Third version is, so we want to see third version of inductive properties. Suppose Pn is a statement for natural numbers. Right. So, what is the meaning of P is a statement for natural or about natural numbers? Right. So, do you understand what is the meaning of P is a state? Pn is a statement about natural numbers. See, for example, for every natural number n, 2n plus 1 is odd number. Right. So, this is a statement. So, my statement is about natural numbers. So for every natural number n, 2n plus 1 is odd numbers, right? This is a statement. Now this statement is about natural numbers, so I can say that my statement Pn is this, right? Can now you can think that there are many such statements, right? So there are many such statements about natural numbers. Can somebody tell me another statement about natural numbers? This is my first statement, or you can say another statement Pn about natural numbers.
For every
Can
natural number n,
uh,
2n is even number.
2n is correct. For n in n, 2n is even. Right? This is a statement which depends on natural numbers, right? Which is about all natural numbers. Can somebody tell me something different? One more statement about natural numbers. This is my statement Pn. Okay, the many statements you have already proved or you know, right? The sum of first n natural numbers. Sum of first n natural numbers is n into n plus 1 divided by 2, or that is 1 plus 2 plus 3 plus n is n into n plus 1 whole divided by 2 for every natural number n, right? This is a statement. So such statements are called as statements which are about natural numbers or depending on natural numbers, and these statements are true for every natural number, right? But our motive is how to prove such statement, because suppose I take 1 2 3 up to 10 and I add them, and then I can verify that this is true. If I take 100 1 2 3 up to 100 and I add them, I can prove that it is true for 100. But is it convenient to check for every natural number, right? It is not convenient to check for every natural number, and therefore mathematics gives us power, mathematical techniques gives us power to prove these statements in one shot, right? No need to work out this calculation for every number. So, and that is what the next avatar of inductive property is. Suppose Pn is a statement for natural numbers, right? This middle part is just for understanding. So what I want to say is, uh, what does the first step? uh, if P1 is true, that is the statement Pn is true for n is equal to 1. P1 is true means for n is equal to 1 statement is true. Uh, uh, for k greater than or equal to 1, for k greater than or equal to 1, if Pk is true, implies Pk plus 1 is true, right? Then what is the conclusion? Pn is true for all natural numbers. So what this says, what it says, suppose we prove that statement is true for first natural number, right? We prove that it is true for first natural number 1, and if we assume that it is true for k, from that, if you are able to prove that it is true for k plus 1, then we can conclude that it is true for every natural number. So how to believe this?
Sir, please repeat, sir. I had some network issue. So could you please repeat?
Okay, so suppose statement is true for first natural number, initial step, and if we assume that uh, if you prove that if you assume that it is true for kth number, and from that if you prove for next, right? If we say if we assume pk, that means statement for k natural number, and from that if you are able to prove that it is true for next, then logically what happens? Already we have proved that it is true for first, and if second condition happens to be true, that means second means what? From k it is true. If we are able to prove that it is true for next k plus 1, then logically already it is proved for 1, and we know that from k to k plus 1 it is true, and therefore from 1 to 2 it is true. With same logic 2 to 3 it is true. With same logic from 3 to 4 it is true, and hence it is true for every natural number. Continue in this way, right? And therefore these two conditions together, what is the conclusion? then statement Pn is true for all natural numbers, right? And so this is called as this is called as first form of induction, first or weak form, first form of mathematical induction or weak form of induction. Later on we'll see the strong form also, right? So what is the first form of induction? Verify if statement is true for first natural number, and if it is a true form k to k plus 1, then it is true for all. And therefore what are the important steps? So important steps to apply weak induction, right? So what are the important steps while applying weak induction? So I will explain this in simpler manner, how to apply weak form of induction. So first step, prove statement prove that statement is true for n is equal to 1. Prove that statement is true for n is equal to 1. The statement is true
Lecture is
for,
being recorded.
yes. So prove that statement is true for n is equal to 1. What is the next step? Second step is assume that. So this step is called as base case. Right, base means initial point. Prove that for n is equal to 1 it is true, and then next step is induction hypothesis. Right, so second step is called as induction hypothesis. What is induction hypothesis? Assume that pk is true for some k greater than 1. This we are assuming, not proving, right? Second step we are assuming. Assume that it is true for kth step. What we are proving in this process, we are proving for n is equal to 1. We are assuming for n is equal to k and prove that. Now next step is prove that statement pk plus 1 statement is true for, prove that statement is true for k plus 1, right? So prove that statement is true for n is equal to k plus 1 using the statement uh, statement for n is equal to k. That is so if we assume it is true for k, then from that we need to prove that it is true for n is equal to k plus 1, means that is pk implies pk plus 1. So pk implies pk plus 1 means we are assuming ki, suppose pk is true, that means for n is equal to k our statement holds to be true. From that, can you prove it is true for next consecutive value of k, next successive value of k, right? So if we are able to prove from k to k plus 1, then by logic, already we have proved for n is equal to 1. And we have, if you are able to prove from k to k plus 1, logically what should happen from 1 to 2 it should be true, from 2 to 3 it should be true, from 3 to 4 it should be true, and hence continuing in this manner it will be true for all natural numbers. And then what should be the conclusion? What is the last step? So first step is conclude that the statement, whatever is our statement Pn, is true for every natural number, right? So these are the main steps of weak induction. Any doubt in these steps? Okay, now the obvious question that must come in your mind is, so the question that should be in your mind, how this induction, how can we believe that from induction the statement is true for all natural numbers? And this is due to inductive properties, because natural number satisfies these inductive properties, these three avatars of inductive properties. And due to these inductive properties, and if you read any set theory book that I told you yesterday, right, and today I told you one more book. So which book I told you today? A foundation course in mathematics. So if you read that book also, you
Excuse me,
can
sir.
find. Yes.
Sir, is this inductive property only valid for natural numbers?
That this is for natural numbers, because this statement about natural numbers, but the property could be about anything. So for example, our main motivation was yesterday's problem. What was our yesterday's problem? De Morgan's laws for n number of sets. Is it clear? Who asked the question? Tell me your name, please.
Aditi Anand.
So what I said now, is it clear?
Yes, sir.
So our main motive was, does De Morgan's laws hold for n sets? For 2 sets we have verified. For 3 sets also it is easy to verify. But if you have 3 sets, 4 sets, 5 sets, 100 sets, that is not sufficient to check for 100 sets. It is not sufficient to check for 2000 sets. Now, if somebody gives you 5 lakh sets, then is it true? And again, the question would be in your mind, when will you come across 5,000 sets? Certainly, in real life, there are many situations. In future, you will come across 5,000 sets, 5 lakh sets when we are dealing with real life situations. Right. So,
Yes, sir.
okay. So,
Sir,
yes,
sir. So can we
yes.
also check the statement that you showed us for infinite number of sets?
Infinite number of, no, it is not about infinite
Not
number
finite.
of sets. No,
Okay.
finite. You take finitely many sets at a time. Doesn't matter how many sets you are choosing at a time. You
Okay,
one
but not
can choose.
infinite.
No, infinite is a different thing that we'll discuss in the next topic, that is sequences and series of numbers. Right? The
Sir,
infinite. Yes.
the step is repeat in
Pardon.
Hello,
Pardon, please.
hello. Can you hear me,
Yes.
sir?
Yes.
Sir, you were talking about like why is only this method of induction validated and not any else?
No. This is the induction about natural numbers, and if you have some statement about natural numbers, how to believe that that statement is true for all natural numbers, and it is sufficient to follow these steps, then we can believe it is true for all natural numbers. Why? Due to the basic properties of natural numbers, which are inductive property. Right?
Okay, okay. So
Ah,
like
that is what the
okay,
speciality about natural numbers.
okay. So like
Right?
if we
And
believe if the
ah,
natural numbers satisfies this property, then we can believe that they are natural numbers, right?
No. Statement could be any statement. Statement could be suppose you have A1, A2, AN sets. In what are the suffixes? Suffixes are natural numbers, right? A1, A2, A3, A4. And suppose you have A1, A2, AN sets, then De Morgan's laws holds for these N sets, right? And this is true for every N, 10, 5,000, 5,000, right? That means
Yep.
this statement deals with natural numbers, right? And if you want to prove that this is true for any number of sets, that means any number of, so what are the number? Natural numbers. So 5 sets, 100 sets, 5,000 sets. So if your statement is about n, it deals with natural numbers. And if you want to prove that it is true for every natural number, then you should follow induction. Is it clear?
Okay, sir. Okay, fine.
Right. That is what the logically meaning of this statement. Your statement could be anything. Right. Okay. So these are the
Sir,
steps. Now, steps are
sir, I
clear?
have a doubt.
Yes.
Sir, I have a doubt in the induction hypothesis step.
Yeah. So induction
S-
hypothesis means what? First step is clear. Prove that statement is true for first natural
yes, sir.
number. And induction
Yes,
hypothesis means assume ki statement is true for kth number. Suppose assume that it is true for 10. K is equal to 10. And
yes, sir.
from that, can you prove for 11? If you are able to prove for 11 from 10, then you are done, right? K
Uh,
to K plus 1, if you are able to prove, then logically you think ki if it is true for 1, that is already proved, and from any kth step to K plus 1 it is valid, then with same logic from 1 to 2 it will be valid,
yes, sir.
right? From
Yes, sir.
2 to 2 with same logic from 2 to 3 it would be valid,
Yes, sir.
right? And continue in this manner. Ultimately, where will you reach? It is true for all natural numbers,
Yes, sir. But I
right?
have a
That is what.
question, sir. That
Yes.
is that assumption? I mean, अगर वहाँ पे assumption ना बोल के हम अगर उसका proof निकाल ना पाए,
No,
मतलब
no, no, no,
assume.
no, 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 no. No. This is very difficult. You cannot directly prove for K, right? You have
Yes,
to
sir.
assume for K, and then from K, can you prove for K plus 1? If you are able to prove from K to K plus 1, then definitely it is true for all natural numbers. So why to waste our energy if you from K to K plus 1 it is true, and for first natural number it happens to be true, then it is true for all natural numbers. That's certainly no need to waste our energy, right?
Okay, sir.
That is
So,
what the
sir,
meaning. Yes.
hypothesis is important in this step, in the
Yes.
induction.
Yes, hypothesis is important. From hypothesis, can you prove for next K plus 1?
Yeah, sir, in
Right?
strong form also hypothesis is required or
Yes, but in strong form, we have to assume from initial to K. Here, we are assuming only for K, and from that, we are proving for K plus 1. But in strong form, we are assuming it is true for 1 to up to K, and from that, you are proving for K plus 1.
okay, sir, okay, sir.
Right? That is the difference. Okay. Okay, so steps are clear now.
Sir, repeat please steps.
First, prove for n is equal to 1. Assume that the statement is true for any kth statement. It could be 10 or 50 or whatever. Assume that it is true for kth step, and from that prove it for k plus 1. If you are able to prove from k to k plus 1, then it is true for the statement is, then we can believe that the statement is true for all natural numbers. So let us see simple example, then it will be more clear, right? So theoretically it might be not easy. So let us take simplest example. Sum of, prove that sum of first n natural numbers is n into n plus 1 divided by 2 for each n, each natural number. Right. Suppose somebody take 10 natural numbers, then what will be sum? 10 into 11 divided by 2. Right. If somebody takes first 100 natural numbers, 100 into 101 divided by 2, whatever that number. Right. But it is not convenient to check for every, but we should have the smart technique. That is a mathematical power. And in one shot, we can give, say that it is true. And that is the inductive property of, right. So inductive property is a key point here which will help us to prove such statements. That is 1 plus 2 plus 3 plus up to n is n into n plus 1 divided by 2. This is true for every natural number. Right, you take n is equal to 10, this is true. N is equal to 100, n is equal to 5000, this is true. And so what is the proof? So we'll prove by induction. And so what is the first step? What is the
For n
step
is equal
1?
to 1.
For n equal to 1.
Prove.
So
Very
proof for n is equal to 1. So if n is equal to 1, then what is the left hand side of the expression? Only 1. No more
One,
numbers. And
only one.
so what is the right hand side? Right hand side is n
One.
into n plus divided by 2. Right. That
1
is 1 into 1 plus 1 divided by 2. That
Divided
is
by
2 by 2. That is 1. And therefore LHS is 1,
E.
RHS is 1. And therefore what is
LHS
statement
equals to
is,
RHS.
so statement is true for n
for
is
n
equal
is
to,
equal to 1.
N
no
equal
doubt.
to 1.
Right. So no doubt statement
Yes,
is
sir.
true for n is equal to 1. So first step is done. Right. Now second step. Step 2, induction hypothesis.
Hypothesis.
Right. So hypothesis means assumption. Right. So in any statement or any theorem, some conditions are given. That conditions are called as assumptions. And from that assumption, we have to derive the conclusion, what we are expecting. Right. So what is induction hypothesis? Assume that.
Assume that the statement is true for n equals to k.
The statement is true for n is equal to k. What is k? K is some number greater than what? Not necessarily it is 10, 5 or 1000. Choose any number and it is some any number greater than 1. That is, now we are assuming. Assuming means we are saying that this statement is true, that for n is equal to k. That means 1 plus 2 plus up to k must be equal to k into k plus 1. Right. We are assuming for n is equal to k, so it must be true. This we are assuming. Now, what is our induction step? What is our induction step? So our induction step is step 3. So prove that
n is equal to k plus 1.
statement is
True for n k plus 1.
statement is true for n is equal to k plus 1. That is what we want to prove now. That is what we expect. What is our expectation? Want what we want to prove. Right. So while proving or solving problems, you have to be very elaborative. Means you should write down clearly what is a given hypothesis and what we want to prove. Right. Unless you write down in detail, you will find difficult to prove many things. Right. So if you want to be comfortable in proving something, so you should write down it in very detail. So what we want, what we expect. key statement is true for k plus 1 that we are expecting, right? So 2 plus 3 plus k plus k plus 1, right? This we are expecting for n is equal to k plus 1. What it should come out, right? For n k, for k it is this k into k plus 1 by 2. And what we expect for k plus 1?
K plus 1 into K plus 2 by 2.
Right. K plus 1 into k plus 2 divided by 2. This we can expect. This is our expected, not proof, right? So how now try to prove our expectations, right? So by induction hypothesis, right? By induction hypothesis, what we have? We have
Sum of k terms is equal to k into k
1
plus
plus
1 divided by
k, 1 plus 2 plus 3 up to k is k into
K plus 1
k
upon
plus 1
2.
upon 2, right? This is what induction hypothesis. Right. Therefore 1 plus 2 plus 3 plus k plus k plus 1, that this we don't know right now, right? Right now we are not sure about this sum, but check what happens. But we are sure about this part by induction hypothesis, this bracket, right? Bracket is already or assumed by our assumption or by induction hypothesis. This bracket is clear, right? And what is the bracket? K into k plus 1 divided by 2. This is a bracket. What is the second part? K plus 1. K plus 1, right? Now simplify this. K times k plus 1 plus 2 times k plus 1 whole divided by 2, right? Do you agree with this?
yes.
Yes, sir.
Yes, sir.
Now
Yes, sir.
in this numerator, now this is numerator whole divided by 2. In numerator k plus 1 is common, right? I can take it outside. And what remains in second bracket? K plus 2.
K plus 2 plus K into K plus 1.
Right. And this is what we were expecting. Right. This is we were expecting. Ki sum of k plus 1 numbers is k plus 1 plus into k plus 2 divided by 2. That what we obtained, right? Thus, what is the conclusion? Right. So what should be my next sentence? What is my
The
next
statement
sentence?
is true for
Statement is
Right.
true for k plus n
true
equals
for
to
n
k
is
plus 1.
equal to K plus 1.
Hence, statement is true for n is equal to k plus 1. Right. So remember that we assume for k, and for k plus 1 we have proved, not assumed. Right. We assume for k, and for k plus 1 we have proved. We took efforts to prove k plus for k plus 1. Right. We spend our energy to prove for k plus 1, not assumption. We assume, we didn't spend any energy in second step. Just assume. In third step, we spend our energy to prove for k plus 1, right? And thus, the statement is true for
All natural numbers.
all natural numbers.
Sir,
Natural
it means
numbers.
that for uh, induction hypothesis, we have to do three steps. First, put n equal to 0 or 1. Then
One.
assume and that we have to put n plus 1. And that by adjusting, we have to do LHS equal to RHS.
That no, adjusting means we have to without violating any mathematical rule, we can prove for k plus 1, right? Not
Yeah,
not
that
arbitrary
is
adjustment.
n equal to k plus 1.
So first for n is equal to 1, we have to verify or prove. So for n is
Yeah,
equal to, we have proved it. For in
yeah.
second step, we are assuming, not here we did not spend our energy, right? We directly assume ki suppose it is true for n is equal to k. But in third step, we have to take efforts. Then from second step, from n is equal to k plus 1, we need to prove. And here we did some calculations, and from that calculation we came to conclusion that the same statement hold for k plus 1, right? Okay, so and therefore 1 plus n 2 plus n is equal to n plus 1 whole divided by 2 for all natural numbers, right? This is true, and this is symbol for all. Many times I will be using such symbols, so you should remember for every natural numbers. Right. So this is clear now. So this
So,
problem
sir,
was
in short, we
trivial
can
actually.
summarize that it is consisted of three steps.
Pardon?
Induction hypothesis. We can consider that the whole induction hypothesis of three steps. Step one is of n equal to 1.
Yes.
Second is of assumption, and third is of we have to prove that whole hypothesis.
Correct. Proof for k plus 1. Right. First step is proof for n is equal to 1. Second step assume for n is equal to k, and third step from
We have
n
to
is
prove the
equal
whole.
to k for n is equal to k plus 1. These are the three steps for induction hypothesis. And from
Got
if
it.
from these three steps we can believe that it is true for all n because natural numbers satisfy inductive properties. Right. Now
Yes, sir.
Sir,
this yes.
sir, uh, in the hypothesis, we have assumed that K is true. Uh, uh,
Yes.
but if somehow there is a chance, no, that it can be false in reality.
No, no,
So
no, no, no.
We are just assuming. We are just assuming. We are not sure about anything. So
We are
for our
not sure,
convenience,
right?
we are assuming.
that
Right.
means the whole system is uncertain, isn't it?
Yeah, but we are
No, 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 no.
proving k and k plus 1 to be equal and hence true. That's why we are,
Yeah.
ending up with the statement that it holds for all n belongs to n.
Okay, let me
Right?
say something. Okay, let me say something. Suppose what his question is, ki suppose for some k it fails, but we have not chosen particular key, isn't it? So we are choosing arbitrary k, and we are proving ki from that k to next k plus 1 it is true. That we are proving, not assuming, right? And then if it
Yes, sir.
happens to be, if it happens, then no, then then you have to believe that it is true for all natural numbers.
Yes, sir.
Right, so think about it logically. This is a kind of logic, so you
Sir,
can take.
then
Yes,
K also should be a natural number greater than 1.
yes, k is a natural number, no doubt.
Sir, one
Sir,
question.
Yes,
sir.
yes,
Sir, this we have proved for natural numbers, the induction for natural numbers.
yes,
But yesterday when we were discussing about the De Morgan's law, those were sets, right?
exactly that I discussed in the beginning. It is not true that your statement involves only natural numbers. It is about natural number. It deals with natural numbers. Right. Okay. What is my next example? Okay, let us take that example. So let A1, A2, AN be sets, right? So how many sets I am selecting? N sets. Suppose I select 10 sets or 100 sets. Then what I want to say is A1 union A2 union and so on union of all
Hello.
these N sets, right? Their complement of union is A1 complement intersection, A2 complement intersection, AN complement, right? So now this statement, we verified this statement or we proved this statement for two sets. n is equal to 2, we verified this, right? N is equal to 2 means what? You have two sets, A1 and A2. Then what we proved last time, A1 union A2, its complement is equal to A1 complement intersection A2 complement. Is it true? This is true. For n is equal to 2, it is true.
Yes, sir.
That is what we verified. Similarly, for n is equal to 3, that
Yes,
means
sir.
take three sets A, B, C. Then it is that you can verify. See, now this statement deals with natural numbers. For how many sets the De Morgan's law holds? Right. De Morgan's law hold for any number of sets, any number of whatever your set. A1 is a set of apples and A2 is set of bananas. A3 is a set of cars. A5 is a set of planets. A6 is a set of books. Whatever you take sets, right? You have different sets, right? And these sets are any sets, but how many sets? That is a natural number, right? Therefore, this
Yes,
statement
sir.
is your question doubt clear? What is second De Morgan's law? Uh, its complement of intersection is A1 complement union A2 complement union AN complement, right? This is a second. For n is equal to 2, second form also proved, right? It is true. So question is it true for this is true for every n in natural numbers, right? That is what the statement deals with, natural numbers, right? So for how many statement is true? For any number of. And how to believe this? So use induction. And therefore, what are induction steps? What are induction steps? So first step, here we have to make slight changes. So prove for n is equal to 2, because if you believe for we need to prove for n is equal to 2, and then second step, assume for k and prove for k plus 1. That is the same steps. So I give you hint. First step is prove for n is equal to 2. That we have already proved yesterday. Is it true?
Yes,
Do we
sir.
agree? We have proved it for yesterday. And now what is the second step? Assume for k, and from that prove for k plus 1, and then we can believe for all natural. Okay, so you try to prove this, and if you are unable, next time we'll see this proof in brief, because our time is over now. It is 2 o'clock and you have to join next class. So I should stop here. Okay, so any doubt?
Sir. No, sir. Thank you.
Yes,
Excuse me, sir.
yes.
Sir.
Sir, is this valid for if you take like integer, then also it's valid, or only for natural number?
Uh,